Hello, welcome back. This is our next video. We're going to keep moving along here, try to get through as many as we can on this third video. As you can see, a lot of these problems are setting up the same thing. We're using the same formula, and we might just be isolating a certain variable, either x, mu, z, or standard deviation, and we can figure out, percentiles where they are on a normal distribution. So moving right along here to keep us going. Once again, hopefully you're kind of getting it. We're going to have a z. We're trying to find a z value of our patients with a CD4 count. So our x is 200 minus our mu of 237 divided by our standard deviation of 43. And that's going to equal negative 0.86. Remember, that's going to equal our z value. We're going to go to the table in the back here and find that is 0.1949 or 19.49%. So the people, our population suffering from AIDS here. Moving along, now we have an HIV keywords here we have to look for is over 375, over, above, greater than. So if we know we're going over, above, greater than, we're going to try to find our value and then take 1 minus that value, because remember, everything in our table is cumulative probability to the left. If we want to find over, we got to take 1 minus that. So when we set this up, our z is going to be 350 minus 237 divided by our standard deviation of 43. And that equals our z. Z is going to be 2.62. Move that to the table, 0.9956. We're going to take 1 minus 0.9956 equals 0.0044. Moving this along, number 18, once again, we're set up. Given a mu, given a standard deviation, and we want to find now what is the 25th percentile of this distribution. So remember, now we're trying to find an x value at the 25th percentile. So x is going to equal, if you want to think of it, our z at 0.25 percentile times the standard deviation plus the mean. Well, z at the 25th percentile is going to give you a negative 0.67 times our 1.9 standard deviations plus our mu of 17.8. Put this all together and you're going to get a value of 16.527. And that is the value of x at the 25th percentile. Now, moving along, what is the z-score corresponding to this? Or what does a z-score correspond to a boy with a BMI of at least 19.27? So now we have an x value here. So now we're going to take our, random drawing. We're going to take our x value of 19.27 minus 17.8, which is our mean, divided by the standard deviation of 1.9 equals 0.7736. Now this is the z. Remember, this is just the z value that we're finding here. And then part C is what is the probability of finding this boy. So if we were to take 0.7736 and move it to our table, we'll find that is 0.7794. Or what is the probability of finding a boy with at least, so keywords here, at least, so it's from, the negative infinity to that point there, cumulative probability. So number 19, like I said, jump down a couple spaces here, which I never really like. But here we have, where are we at? We're looking somewhere. I thought we were in a specific spot. An investigator is looking at periodontal disease and onset of hypertension. And so part A has us assuming the mean of the distribution is 176.2 centimeters with a standard deviation of 17.5. We want to find the lowest 1% and the highest 1%. So the lowest 1%, if you think of the outlet, is z.01, and the highest is z.99, right? If you're in the 99th%, that's the highest. There's only 1% of people above you, and the lowest 1%, 0.01. So we're going to be using, and we're finding, what is that height? So we're trying to find a value of x. So x, remember, is going to equal our z percentile of 0.01 times our standard deviation plus our mean. Same thing down here, but the z of 0.99 times standard deviation plus our mean. When we find these values, you get negative 2.33. And if you think about it, the graph of this distribution is always going to be symmetrical. So the value up here is going to be kind of the inverse down here. So if you know that the lowest is 2.33, well, the highest has to be 2.33 as well. They're exactly the same distance away from the mean at the highest and lowest 1%. We're going to times it by our standard deviation of 17.5 plus our mean of 176.2. Write it down here as well, plus 176.2. And then our lowest value is 135.425 centimeters. And our highest value is 216.975 centimeters. So this is the lowest and highest heights in this population given their mean and standard deviation. Part B, all we're doing was just changing the mean and we're changing the standard deviation, but we're still using the same values of the lowest and highest 1%. So we're going to take negative 2.33 as our lowest value here, times our new standard deviation of 16.1, adding it to the mean of 184.8, you get a value 147.287, and positive 2.33 times 16.1 plus 184.8 equals a value, this is centimeters, sorry, of 222.313 centimeters. Anyway, use what's around. If you already have done problems before and you know the values, you don't have to always keep constantly going to the back re-looking at it. Once you have those values, you're good to keep going. Use what's around you. Number 20 here, we have MCAT score given a new mean and a new standard deviation. So we want to know what proportion of test carrier score above 170. Keyword here is above. So we're going above 170. So everything, if we want to kind of draw this out, right? You're going to have your mean 150, and we're going to have a value, let's say this is 170, but we want to know above. So we want to know everything over here, because that's always, these values are always above 170. So we know we're going to have to take 1 minus that, because everything in the book is going to tell us from that value and to the left, or less than that. So we take 170 minus 150 divided by our standard deviation 95, get a value of 0.2105, bring that to the table, 0.5832. Now remember, we want to find everything above that, so 1 minus 0.5832 equals 0.4168. This is not drawn the scale, obviously, because 170 I put way out here, but truly one standard deviation up it would probably be about here, and that's going to be 200 something, so 170 would probably get here. So this is the true kind of value we're finding here. It's going quick, just to give you the idea of what we're looking at here. Next part, suppose only those in the top of their class are eligible for financial aid. What score in the exam correlates to the top 5 percentile. So here, top 5, if you're in the top 5 percentile, that means 95% of the people are below you. So we're having our z of 0.95, which if we look at that, that's 1.648, and we want to know a score on the exam, so we're trying to find a value of x. So x is going to equal our z of 0.95, which is 1.645, times our standard deviation, which is given above at 95, plus our mean of 150. We write all that out, calculate it. Remember, if you put all this in the calculator, make sure you use your parentheses appropriately. If you don't, your calculator could, calculate things wrong for you. So just remember your please excuse my dear Aunt Sally, or break it apart piece by piece and do it yourself. And then the score in the exam that you need to be in the top 5 percentile is 306.275. Moving along for number 21, so the key things we're looking at here is we're looking at the top 5, 10, and 1 percentile given a new mean and a new standard deviation. So now we're still trying to find the value of x. we're trying to find the value of score given a mean and standard deviation, and we're given these percentiles. So if you're in the top percentiles, we're looking at a z percentile 0.9, which would be the top 10 percentile, a z of 0.95, which is the 5th percentile, and z of 0.01. We're doing the very same things. Remember, there's a little kind of, I wouldn't say a cheat sheet, but there's values that are used very often and are great ones to have marked down on the side so you constantly don't have to keep looking them up. But once, and these ones are 3 kind of big main ones here, the 90th, 95, oh, I'm sorry, this is going to be 99th percentile. 0.01, that would be negative 2.33. We're going to add our mean to each one of these, and these would be the scores or the value of x at each of these percentiles that you need on an exam to get. So if you wanted to be in the 95th percentile or the top 5 percentile, you would need to score 152.965 at least to get there. If you wanted to be in the 99th percentile or the top 1%, you'd have to score 164.61 on the exam to be in the top 1%. I'm going to stop there because there's not very much time, and the next ones are kind of multiple choice working out ones. So I'll stop here and I'll see you all in the next video.